Mason's awesome 7.3 Sum and Difference Identities math video. See, as we go through our math, we will stumble upon these things in trigonometry, and we're going to find values that are not on our loved unit circle. When we stumble upon these, don't panic. We have actual things we can do to solve these. You can play with addition and subtraction using various combinations of values that are on the unit circle. And it's just a piece of cake. This brings us to today's objective: to know how to use sum and difference identities to solve trigonometric problems. Now, before we begin, we'll need weapons to defeat this lovely pre-calc monster. And in math, what better weapons do we have that's better than formulas? Hey, don't boo. I know they're annoying, but they're useful. This one has three forms: for sine, cosine, and tangent. For cosine, we have cosine is equal to little fishy plus or minus b/p baby is equal to cosine of little fishy times the cosine of the p and b baby plus or minus sine, I'm running out of space, fishy times the sine of the little p and b baby. Now, we're going to make a slight note right quick, and I'll explain it later on. But these two little things are opposite of each other. That'll get more clarification as we do our examples here in a minute. For sine, we have sine little fishy plus or minus p and b baby is equal to sine little fishy times the cosine of little p and b baby plus or minus the cosine of little fishy times the sine of little p and b baby. One more little note. These ones match. That'll be explained in just a second. And for the last weapon, we have tangent, and tangent, little fishy plus or minus p and b baby, a little repetitive, I know, is equal to, slightly more complicated, tangent of fishy plus or minus the tangent of the p and b baby over 1 plus or minus the tan of little fishy times the tan of little p and b baby. One more side note. The top ones are the same, and the bottom one is the opposite. I know this is a little confusing right now, but again, in examples in just a second, you'll make a lot more sense. Now you have been armed, let's try out a problem. As you can see, I've already made a little unit circles just so we can have our old friend back, and I forgot how to use the board. So, can I make this smaller like so? Perfect. And then I get back my trusty little marker, and we begin. For our first problem, we're going to try a sine problem. Let's go with the sine of 165 degrees. That's a 5, trust me. There we go. You see, this is not a value of the unit circle. However, the values of 120 and 45 are on the unit circle. And when those are added together, maybe, we will have 165. Now, think back to that little equation I had you write down earlier. This is our little fishy, and this is our p and b baby. Now let's just plug it in. It's a simple plug-in check. You have the sine of 120 times the cosine of 45 plus, that's where the thing comes in, because we're adding here in our little equation, that's what it's called. We're going to add in our formula. If we had subtracted some values to make 165, we would have used a subtraction sign in our formula. Make sense? Perfect. Plus the cosine of 120 and the sine of 45. Now, don't get out your graphing calculator and try to find the values of these. We go back to our little unit circle, and we already have values. Because the thing we're doing is in degrees, we're going to use the degree value. Let's go to the sine of the value, I should say, of 120. And we have our trusty little values for the coordinates. And just to save time, I can already tell you that you're going to get something like this. Negative root 3 over 2 times root 2 over 2 plus 1/2 negative 1/2 times root 2 over 2. Now, all you have to do is solve the problem. You multiply these values and you get root 6 over 4 plus root 2 over 4. And that becomes root 6 plus root 2 over 4. That's a 4. Ta-da! It's not that difficult, it's just ugly. No offense, math. A beautiful part of this is that most of the problems you do will use root 3 over 2, 1/2, and root 2 over 2. So it's never too complicated. Anyway, let's show a cosine problem. It's possible to create another one of those to put on the third and fourth. We'll have our lovely tech guy in the back help us with that. Shout out to Mr. Arthur, thank you. Now, for the cosine problem, we're going to kick it up a notch. It's going to get slightly uglier because we're going to use our old friend radians. Ew, I know it's ugly, but it's not that bad. Let's solve for the cosine of pi over 12. Yeah, I know you're complaining. Shh. Okay, once you use the radians version on the unit circle, you'll notice values that actually can be used, they're fractions, so they can be changed to have 12. You'll find on the unit circle that the values pi over 4 and pi over 6 actually subtract to equal pi over 12. When you take this and multiply it by 3, you have 3 pi over 12 minus this multiplied by 2, you get 2 pi over 12, and that becomes pi over 12. And then we take our cosine problem, which requires a lot of writing. Tedious, I know. I'm going to have to erase that real fast, just to make it a little simpler in our writing. Maybe. There we go. Now you're going to have is equal to pi over 4 minus pi over 6. You go back to the unit circle, you find the values that will be found for those, the coordinates that make cosine for pi over 4. You'll find it is, and plugged into our equation, you have root 2 over 2 times root 3 over 2 plus, now because this is a cosine problem, these are different. This and this, they're opposite. Make sure you get that or else your answers will be wrong when you actually do the problems. Times root 3 over 2 times 1/2. All those values look familiar? They should. When you multiply them, you get root 6 times root 2 over 4. Okay. One more notch up is the tangent problem. Dun, dun, dun. Oops. Yeah, there we go. Okay, for the tangent, let's find the tangent of 23 pi over 12. Yeah, I know, that's even uglier. But you're going to be able to find radians that equal 23 pi over 12 using the same process we did last time. For this one, you'll find pi over 4, our lovely friend, and 5 pi over 3. This becomes 3 pi over 12. And this becomes 20 pi over 12. And that combines to get 23 pi over 12. We'll erase it once more to get some more room for our equation, because you know you're looking forward to that. And let's begin. Let's put it into our formula. Tangent of 23 pi over 12 is equal to pi over 4 plus 5 pi over 3. When we plug it into our formula, you'll get tangent of pi over 4 plus, notice because this is a plus, on the top it is the same, 5 pi over 3 over 1 minus the opposite of what we have up here, the tangent of pi over 4 times the tangent of 5 pi over 3. This becomes, once you find values of the unit circle, you'll have 1 plus negative root 3 over 1 minus 1 times negative root 3. When you simplify this, you will get 4 minus 2 root 3 over negative 2. And then once you simplify this by taking the negative into each other, you will get our answer over here of negative 2 plus root 3. See? None of this was that hard. It's just slightly complicated and a lot of paperwork. But I hope this was able to help you meet the objective. You should now know how to use sum and difference identities to solve trigonometric problems using cosine, sine, and tangent. Have fun saying awesome pre-calc monsters. Bye!